Hi everyone, welcome to my talk, Leveraging Yara Rules to Hunt for Abused Telegram Accounts. I want to start by asking you all, how many of you are members of illegal groups or channels on Telegram? Okay, I understand why nobody raises their hands. Let's begin. In my research, I found that almost 50% of the Telegram accounts that I checked abuse the platform in one way or the other. Let's start by telling you the 6 takeaways for my talk. The first thing is that I will show you how you can use IoT global search engine for your own purpose. In my case, I use it to hunt for abused Telegram accounts. The second thing is that you will understand how to leverage Yara rules to hunt anything you want and not only malware. For the ones of you that work as red teamers, I will show you how to use Telegram to create a command and control server. And for those that are on the blue side, I will show you how to protect yourself from such kind of threat. And one last thing, I hope you will get ideas for your next talk, just like happened to me. I'm Asaf Aprozper, the head of research of Aprozper. Aprozper is an IoT global search engine which protects companies' assets by scanning all of the global internet on a daily basis. To perform that research, I had to take advantage of Aprozper's data. I am passionate about helping the community, especially with Yara rules. You can find some of my created rules on the official GitHub of Yara rules. I am the creator of the known tool Coffee Shot, which I was presented at Black at USA 2018. And lastly, I'm excited to be here for my first time at Cold Blue Japan. What is cybercrime? Cybercrime is a criminal activity that involves a computer or other networking device. There is a long list of cybercrimes, such as fraud, money laundering, identity theft, as well as many others. In the past, if you wanted to get into the cybercrime districts, you will have to be a hacker or a coder. Over the years, it has become easier to enter the darknet, and it's come to the point of using Google to find darknet markets or websites that publishes the latest darknet market links on the darknet. However, the darknet is a difficult place to navigate. It is complex and risky. It is correct that anyone with a Tor browser can get in the darknet, but it will take them some time to find the forums with the closed chat rooms where people are selling the most evilest items. The darknet is a hive of illegal activities, starting from drug dealing, selling of guns, stolen credit cards, ransomware as a service, and illegal pornography. Buyers and sellers use this medium to trade and exchange both knowledge and products. This is, of course, until the long arm of the law comes in and shut them down. The takedown of such darknet marketplaces, Hansa Market, Alphabay, and Dream Market, by the law across the world, made headline news from time to time and served as the latest example of how this cat and mouse game works. While there are still numerous websites operating under the same premises in both ClearNet and Darknet, the previous examples just indicate how vulnerable these sites can be. From a hacker hobby into a capitalist market, as long as there are illegal products and money to be made, there will always be criminal innovators developing new ways to trade. The darknet users, customers, seem to have reached to the same conclusion too, as well as migrating to a more secure and easily accessible platform. From the criminal perspective, it wasn't long before they shifted to new channels on the surface to evade the law and continue their cybercrime. An example of such a channel is the increasingly popular mobile messaging app Telegram to continue their cybercrime. In my research, I found that Telegram has become a popular tool for delivering cybercrime. So let's dive into the presentation and understand why Telegram becomes so popular for cybercrime. Telegram itself launched in 2013, and it's an encrypted instant messaging application with 200 million active users monthly. However, what sets Telegram apart, among other features, is the pride placed on their improved security capabilities, including private end-to-end encrypted chats. The Telegram app allows you to create groups with up to 30,000 members. Groups can be best described as closed chat rooms in which all members can read, comment, and post. In my research, I found this is the place where cybercriminals advertise, connect, and share knowledge and compromise information, just like what happens in the closed dark web forums. Telegram also has a nice feature called channels that can be used to broadcast messages to an unlimited number of subscribers, and their entire messaging history can be viewed. Attackers mainly use Telegram channels to advertise fraud services and products. Another thing is that by using Telegram, you have the option to share files of nearly any type. In my research, I found malicious use of that feature by Telegram command control servers that contain zip files with the stolen data from the victim computer. Another benefit of using Telegram for cybercrime is that anyone with a shady offer can enjoy encrypted chats and hidden identity instead of the exposed threat that are seen in the online web forums. If in the past several steps were required to ensure an anonymous connection to Tor, today any Telegram user can easily and quickly join channels with a single tap on their phone and start to receive notifications of secret conversations and shady offers directly to their smartphone, all while keeping their identity completely hidden. So I already told you about the Telegram channels and groups, but the most known Telegram feature for cybercrime is the Telegram bots. Telegram bots are a popular feature allowing third-party apps to run within the platform. They have a rich set of features and quick adoption. Bots can be set up for specific tasks, and legitimate users are automatic file converters, daily weather, as well as many other legitimate services. The Telegram bots are cybercriminals' next step because they include several significant benefits such as automatic cybercrime and remain invisible. No need to register a host and a domain, which eliminates all of the typical security challenges that might impact a website. DDoS-style attacks become irrelevant. What? Someone will try to DDoS Telegram web servers in order to take down some Telegram user? Using Telegram bots also eliminates the need of cybercriminals to protect and hide their website from law enforcement. Anyway, this is also what I thought before my research. Another thing is that the implementation of Telegram bots in the fraud context is relatively new, which makes the law enforcement unaware of that. As a result, Telegram has become a valuable alternative to the darknet. In my research, I found that malware that uses Telegram as a command and control server uses the Telegram bot API for sending commands and communication. The following link is an example of the bot API request that's used by malware in the wild. As you can see, the request contains the bot API token, which is built from the API key and API hash, and there is also the getMe function, which is colored in blue. I will explain the purpose of the getMe function in the next few slides. The latest malware, which uses Telegram bots as a command control server, called Mossad Stealer. The Mossad Stealer is sold as off-the-shelf malware and advertised in underground hacking forums and dedicated Telegram groups. It is a stealer malware capable of stealing browser data, including saved credentials, login forums, and credit card information. They even have support groups on Telegram in English and Russian. The Mossad Stealer sends all the information it collects and also receives commands from a Telegram bot that's controlled by the attacker. This is a screenshot of the malicious pickup that I captured using Burp. As you can see, the request contains the bot API token and the getMe function, as I explained to you before. In that case, the getMe function is used to verify that the command and the control server is up and ready to get the stolen data from the victim computer. If it will be up, the response from the command control server will contain the bot details, which looks like that and contains the bot ID, first name, and username. Once the Mossad Stealer makes sure the command control server is up, it will use the send document Telegram API function to send a zip file with the stolen data from the victim computer. As you can see, there is the zip file with the file name. There are also already frameworks to create Telegram command control channel for your malware and can be found on GitHub and Google. This one is called Brain Damage, and it's written in Python. You can scan the barcode if you want for the link for the framework, for direct link for the framework. This is another framework for Telegram command control channel, and as you can understand by its name, it's written in C#. You can also scan the barcode if you want for the link. Those are screenshots of the commands the Telegram bot's command control server supports. As you can see, the C2 commands are very similar to a regular C2 server that we all know, such as the sysinfo, who am I, reverse shell. This one is another example of how looks Telegram bot's C2 from the attacker's perspective. On the right side is the C2 log terminal, and on the left side is the C2 bot executing commands on the victim computer, like get SCR. So, leveraging Yara rules to hunt for abused Telegram accounts on the internet. Let's talk about the research itself. How did it start? Before a couple of months ago, I attended a talk at the B-Sites TLV conference. The talk presented a PhishItKit campaign that used Telegram bots as a CNC server. During the talk, I had a spark and wondered to myself, is it possible to hunt for Telegram C2 servers using IoT global search engine? So I started my research, and my first obstacle was the need to hunt for a specific string in a large number of web pages. As we all know, the using of Python operators or regex on such a large amount means slow performance, which takes us a long time to get some relevant results. Because of that, I decided to use Yara rules. My affair with Yara rules started a couple of years ago when I started to work for a large AV company. Since then, I published a couple of sophisticated Yara rules to hunt malware, and I thought it can be a great idea to use it for my research. Also, using Yara compared to other methods has proven to be more effective with high performance when dealing with mass amount of data to scan, including options to create unique combinations and involve heavy regex to hunt for specific data. Just for you to understand the size of the difference, I tested the performance between Yara and Python operators, and the result were that with the Python operators, it took me about 32 seconds, with 150 function calls, compared to using Yara rules, where it took me only 0.008 seconds with only 10 function calls. I tried to create a graph to show you that, but because the difference in the performance, in the numbers of the performance was too big, you will not see any colors in the Yara rules column. My next step in my research was to write sophisticated Yara rules, which involve heavy regex for capturing Telegram join links, Telegram account web pages, and expose Telegram API tokens on the global internet. Overall, in my research, I created 3 Yara rules. For the first Yara rule, I analyzed the source code of the Telegram web pages accounts, which looks like that. Then I used the source code of the send message button to capture the Telegram username. This is the HTML source code of that button. As you can see, it contains the name of the bot of the Telegram account. In that case, the name of the bot was a Aprozper bot. This is a screenshot of the first Yara rule that I created to hunt for Telegram account web pages on the internet. As you can see, it contains some heavy regex. For the second Yara rule, I wanted to expand my research by capturing Telegram links that were published on the internet. Some of the most malicious ones that I found were posted on comments for YouTube videos that people can easily and quickly join. This is an example, in the green text, is an example for the link structure for joining a Telegram account. And this is a screenshot of the second Yara rule that I created to hunt for Telegram links on the internet. As I explained a few slides ago, malware that uses Telegram as C2, command control server, uses the Telegram API function for communication. The following link is an example for that HTTP API request. I was very curious if I could capture such as exposed Telegram API on the global internet. So for that purpose, I created my third and last Yara rule. And here is it. My third Yara rule to hunt for exposed Telegram APIs on the internet. Don't worry, in the end of my talk, I will present a link to my GitHub where those Yara rules will be published. So once I had my Yara rules written, I combine it with Aprozper IoT scanner to hunt for exposed Telegram stuff on all over the internet. I stopped the scanner after a couple of minutes because the list was big enough for my research. You can also scan the internet yourself and combine it with Yara rules. If it is by using the API of one of the known global IoT search engines or using open source tools like ZMap. I commend you to do that. You will be surprised by the things you will find using Yara rules and exposed to the internet. Following getting an output list of a long list that contains Telegram accounts, I started my next step in my research by utilizing Telethon. Telethon is Python 3 library to interact with Telegram API as a user or through a bot account, and publicly available on GitHub. You can scan the barcode if you want for the link. So let's stop for a minute and take a look at the steps that involved in my research until now and how it worked. The first step was to create and leverage the Yara rules to hunt for Telegram web pages, links, and APIs that expose to the internet. Step 2, scan the internet with my Yara rules. Step 3, gain an output list of Telegram usernames. Step 4, using Telethon to divide those usernames into groups, channels, bots, and users. At this point, I ran into another obstacle that I was blocked by Telegram because of API limit. At this point, I ran into another obstacle that I was blocked by Telegram because of API limit. Sorry. I tried to manipulate Telegram API and found that Telegram blocked you for 24 hours after doing about 200 API requests, meaning checking only 200 Telegram accounts daily. That wasn't enough for me. So I overcome the Telegram API limit by purchasing a large amount of SIM cards. I found that once you created an API for a SIM card, you don't need an active Telegram session later. Meaning that you can create a config file with Telegram APIs, and when it will get an API limit exception, the script will continue by using the next API from the config file that you created. After overcoming the API limit, I insert to my POC code some suspicious identifiers based on Telegram command and control open source frameworks and for malware in the wild that I found which uses Telegram as command control server. The following screenshot is the result. It contains multiple languages such as Arabic, Persian, English, and Russian. At that point, I started hunting for abused Telegram accounts by the following diagram. Using one of the many features that Telethon has, I was able to discover whether some Telegram account is a bot, channel, group, or regular user and take action accordingly. In one case, where I identified a group or a channel, I used Telethon again to iterate on all over the history messages and capture those who are matched to one of the suspicious identifiers that I insert earlier. In another case, where I identified the account as a bot, I utilized Telethon to send message commands such as start and help to the bot, analyze the output, and capture those who are matched to one of the suspicious identifiers that I insert earlier. At the end of my talk, if you will have time, I will show you what happened when at the beginning of my research, I accidentally detected regular users as a bot. It will be funny. This is a screenshot of my POC tool in action. As you can see, I started by connected with some SIM card. Then it tested the first Telegram account in the list, sent him message commands, and waited 30 seconds before it analyzed its response. In that case, it discovered a malicious bot. In testing number 2, the tool detected a malicious channel or group by searching for one of the malicious identifiers that I insert earlier in its history messages. In my research, I found Telegram bots that leverage the app to perform malicious functions, starting from command control servers and progress to create a bot that help users tailor and order their perfect woman for a night based on the options they chose, like hair, weight, and area. I also found black market channels and some closed hacking groups. Here you can see a screenshot of the Mossad stealer that uses Telegram as a C2 server and got hunted by my script. This one is another malicious Telegram bot C2 channel of the Mossad stealer that also got hunted by my script. You can see all the stolen data that the victim stole, that the attacker stole from the victim computer. And here is another malware which uses Telegram as command control server and looks like another variant of the Mossad stealer. In the following screenshot, I hunted a Persian darknet channel which published a rat for Windows. The rat, as you can see, called spy note. This one is an automatic bot for buying stolen credit cards and has already been deleted. Here you can see the bot that by pressing any one of the buttons, you can order a woman for a night based on the age, hair color, and weight. This is a bot for ordering drugs to your home, just like what happens in the darknet. So we already talked about how I used my 2 Yara rules to capture Telegram links and accounts on the internet. However, I didn't talk yet about the results for my 3rd Yara rule that I created, hunt for exposed Telegram APIs on the internet. Once I hunted the Telegram API tokens that belong to a malicious threat actor, if it was on VirusTotal or Hybrid Analysis or other threat intelligence websites, I was able to access to all of its history messages by abusing the forward message API to forward all the bot history messages to my account. The forward message API structure looks like that. It is built from the chat ID that you want to forward the message to. In that case, my chat ID was in the green, and the chat ID of the malicious bot itself in orange. But as you can see, there is also the message ID, which in red, and contains the number of the message to forward. In my research, I used that to write a simple Python script that will iterate on all over the numbers, starting from 1 and until it will get an exception. And by that, I got all of the bot history messages from the first one until the last one. So when I forward the first message from the command control server, the bot, I got the start command that the attacker executed to start the C2. The next messages contain details of the victims with their stolen data. In order to protect your organization from malware that uses Telegram as a command control server and find its way out of your network, I recommend you to block the domain address api.telegram.com. telegram.org on your firewall or in your other networking security systems, so the stolen data will not reach to the command control server. So as I said before a couple of slides, in a case that I detected an account as a real user, I skipped it and moved to the next username. But at the beginning of my research, I made a small mistake when I sent message command to real users, and as you will see, the result was funny. Here you see someone that said to me that he isn't a bot, and he is a programmer, and wanted that I will hire him. In the end, he tried to stop me by sending me a stop command. In that screenshot, you can see that someone got enough for me and for my message command, send me a funny gift to show me that. And here you can see that someone went crazy for not understanding what I want from him. In the end, he tried also to call me. I didn't answer him. So, taking out the trash. Cyber criminals that leverage Telegram for conducting cybercrime it's not necessarily new. As I speak, my script is hunting for more varieties of cybercrime on different types of Telegram accounts. It doesn't matter if it's a bot, channel, or group. Everything is taken into account. Through my research and the tool that I created, I reported to abuse@telegram.org on such abused accounts to help to shut them down. So what's next? Improving my script. You can also help me by sending me pull requests. I will continue hunting for Telegram accounts that are using the platform for malicious stuff and trying to make it a better place. And the last thing, I want to focus on hunting for exposed Telegram APIs on specific threat intelligence websites, such as VirusTotal and Hybrid Analysis, and also other sandbox websites. Because I found in my research that this way I had more chances to hunt for Telegram C2 servers. Thank you, everyone. The POC code for my rules can be found at the following link. You can also scan the barcode for the link or take a picture of it if you want. So thanks to everyone.